Hello, good evening, or good morning, wherever you are. Welcome to my channel. My name is Mark Harris, and today we're going to be talking about diagram 9. Here's a brief look at diagram 3, in case you haven't seen it before. You should watch my previous videos. And diagram 8. And diagram 9 is based on diagram 8. There'll be links in the description to look at these previous videos I made. Now here's diagram 9, and what it is, it's a backup power supply. And why would you want one of these during an electrical blackout? So I'll point out here, go through it here, point out what's different about it than from diagram 8. This is a battery, an automotive type battery, 12 volts. And it's connected to an inverter. Inverter, what it does is inverts or changes 12 volts DC into 120 volts AC. When you buy one, make sure you buy a pure sine wave inverter. Don't get a modified one because those are square waves and they won't work. So they won't go through a transformer properly. A transformer needs a continuous sine wave for them to operate. And what you're going to use here is a battery charger. And battery chargers have transformers in them, so they can't operate on square waves. They have to have sine waves. So here's the three transformers. They have to be 240 to 240 volt transformers. And we're passing 120 volts through them. And then we're making two parallel branches. Well, here's one right here. And the other one's down here, the secondary. So we have 240 volts present at these transformer T2 and T3. But we're passing 120 volts through them, so 120 volts is coming out. And then they're wired in parallel to the load. And one of these resistors should be a battery charger. And the battery charger, the cables of the battery charger go back to the battery. And they keep the battery charged with the free electricity that we've created. It was not really free electricity, but it's recycled electricity that we've created with diagram 8. And the other resistor could be a heater, a light bulb, whatever you want, or it could be connected to your furnace during an electrical blackout, as long as you got natural gas still operating. Say there was a big storm or something and the power lines went down in the wintertime, you would want this in your house. What else could this be used for? You could use it in your vehicle. Let's say you're traveling during the wintertime and you get stranded in a windstorm and you're stuck. How are you going to keep warm if you had one of these in your vehicle, even a small one? You'd be able to keep warm and have a light or something like that and survive. And what else can be used for in a vehicle? Well, you can use them in electric vehicles. And you'd be able to keep your batteries charged without stopping to charge them up. I don't have a prototype of this yet, but I'm waiting for one transformer to come. And I'll be using diagram 11, where I keep it all at 120 volts. And then I'll know for sure if I can keep the battery charged to run this inverter. Because if the battery goes down below a certain level, then the inverter shuts off. But if you have a battery charger charging the battery, then the inverter is going to stay on and you're going to keep supplying 120 volts to this circuit. And, you know, if you have more batteries, more than one battery, you can have more than one battery charger hooked up too. It just depends on the VA ratings of your transformers, and the inverter has a VA rating too. So, you know, I've got a 1500 watt inverter in my basement that I use for this. But you can get them larger too. And I guess that's all I need to say about all this for now. If I think of something else, I'll put it in the description or comments. Okay, I guess that's enough. I'll talk to you later. Bye.